Well, welcome back. This is the second video for the Lagrange error additional practice worksheet. This is problem 2, and it's asking us to find the error bound using Taylor's theorem for E approximated using 1 plus 1 plus 1/2 plus 1/6 plus 1/24. So what we need to do is take a look at what the terms are. So we'll also we're finding the error, so we need the remainder term. So there's the general remainder term from the general Taylor series. And let's take a look at the Maclaurin series for e to the x. That's one you should have memorized. So remember, e to the x is 1 plus x squared over 2 factorial plus x cubed over 3 factorial, etc. If you compare that to what they gave us for our approximation for e, we're looking at e to the 1. And so 1 is replacing the x. And we're going up to 24, which is the same thing as 4 factorial. So that's the 4th degree Taylor polynomial. That would be known as like P4 of x. So, P4 of x. So what we're looking for is the 4th remainder. So the 4th remainder is the 5th derivative of c times x to the 5th over 5 factorial. And remember that c is the place that the derivative will give us the highest value, the maximum error. Because remember, this is the error bound, so it's the biggest error that we could possibly have. So that's R4 of x. What we need to do is just find all the different pieces of this. So we need the 5th derivative. Well, since we're dealing with e to the x, it's really quite simple. The 5th derivative of x, all the derivatives of e to the x are e to the x. So the 5th derivative is e to the x. Then we need to figure out where is e to the x the largest on our interval. And our interval is where the Maclaurin series is centered at, 0, up to what we're estimating, which is e to the 1. Remember, that's e to the 1. So the highest value of e to the x on that interval from 0 to 1 is when x is 1. So we want to know the 5th derivative of 1, which is equal to e to the 1. All right, so as we continue to fill this out, we get the absolute value. E to the 1, of course, is just equal to e. And then we want the biggest value of x on that interval. And so again, same interval, 0 to 1, so that's times 1 over 5 factorial, which is 120. Okay, so that ends up being our value. We have e over 5 factorial, e over 120. I meant to bring up my calculator to be able to calculate that for you, but it turns out that ends up being 0.2266. 0.22. I'm sorry, try that again. 0.02266 is our approximate error. Of course, that's been rounded. And that's a pretty simple problem. I'll be back with example 3 soon.